Okay, let's try to understand what hopping or the concept of hop number means when we're talking about packet switching. Now, basically, hopping is a phenomena is when a packet gets lost because they keep bouncing around from router to router and never actually reach their destination. Now, basically, if you see here that these are different routers, and let's just say there's a packet that ends up at router 5, and router 5 determines that router 3 is the next route that it should go to. It goes from router 3 to router 7 because it determines that router 7 is the best place to go to. Router 7 for some reason determines that it go to router 8. The router 8 brings it back to router 5. Now, that packet ends up in all of these routers and came back to router 5 again, and it can happen any multiple times. It can go to multiple packets and routers and then end up at router 5. And because of this, we can see that this packet is simply just bouncing off between different routers and ending up at that same position. And because of this repeated transfer from router to router, it will never eventually reach my destination. This concept is known as hopping, and it is a very frequent thing because each router, for some reason, it may determine that this a particular hop from one router to the next is the best possible way to go, and that decision may cause a packet to end up back at this original position, because it could be any number of reasons. For example, router 7 determines that, okay, I have to go here, but right now all of these routers are busy, so I have to move from somewhere. Let's just see, send it here. And this one sees that, okay, for the best possible way to get to here, I need to first transfer it to router 5. This is where it originally started from, and this is hopping. And it can happen for any duration, any long, it could happen endlessly, right? Now, this bouncing around from router to router is without reaching the destination is a big problem. Not only does the packet not reach its destination, it causes the routers that are involved in this hopping to be excessively busy in identifying where a route packet has to reach, how a packet should be forwarded, and that packet never reaches its destination. Now imagine that if I have, instead of just one packet hopping around, I have multiple packets hopping around. That means each router may end up and becoming endlessly busy in determining and calculating the router a packet's next position without ever that packet ever reaching its destination. So that's a huge problem. So hopping should be taken care of, right? Eventually, the network would just get grind to a halt as the number of lost packets mount up, clogging up the system, and each router is basically just busy in working with packets that will never reach their destination. Now, a solution is this is solution to hopping is to add a hop number. Now, basically, a hop number, for example, this you can see here in this diagram, a hop number assigned to each packet is say 10. Now, what 10 means that each time a packet bounces from one router to the next, the hop number is decremented by 1. So if I started off, say, for example, 10 is not 10, it's just one example of 10 here. Okay? It could be a bigger number than this, but let's just say the hop number is 10 for this particular example. A packet is assigned a hop number 10. Each time a router is each time a packet is forwarded from one router to the next, the hop number gets decremented. And every successive hop from one router to the next results in my hop number being decremented. Now, eventually, it will come back to 0. It will reach 0 at some point. Because of this, when that packet reaches with the hop number 0, reaches a router, the router will see, okay, the hop number is 0. That means this packet has possibly been through at least 10 different routers and it still has not reached its destination. So there is a great chance that this packet may never reach its destination, and to avoid this endless hopping, that router which discovered the hop number to be 0 will discard this packet. It will be deleted and it will not be forwarded to the next router. This simple technique of adding a hop number, a limited hop number, will end this problem of endless hopping from one router to the next. So each packet is assigned a hop number. The hop number is decremented each time a packet is forwarded from one router to the next. And this hopping from one route to the next, eventually reaching to the destination, is allowed as long as the hop number is not zero. So again, the hop number is in principle determined in such a way that at least during that hop number, that packet should at least be reaching its destination. But if it is a such packet that will never reach its destination, this hop number will prevent that, because it is a limited quantity. Each time the hop is carried out, it is decremented, and eventually when the hop number becomes zero, the router that received such a packet, the hop number zero, is simply discarded, eliminating the possibility of endless hopping between the routers. So this is one very elegant, very simple solution to avoid my network becoming overwhelmed with packets that will never reach its destination. Again, I repeat, the hop number is settled in such a manner that it is assumed that at least the packet should be given a chance to reach its destination. But if, for example, it is not reaching its destination in say 100 hops, within 100 hops, or within a 50 hops, that means it might never reach the destination. And to avoid the possibility of it clogging up the system, we simply delete it. If the hop number has become zero, we simply delete it. Now, this is the concept of hopping.